So, let's do this, because this will be a nice review of what you have to write for these proofs anyway. Well, so we're trying to show the limit as x goes to a of c equals c. Can somebody tell me what is f of x? Let's identify a few things. What's f of x? C, holy shit. A is a, right? And you see why it doesn't matter what the limit is, because it's always going to be c no matter what. So that's one kind of giveaway here, is they're not being specific here because they don't have to be. So a is a. So given epsilon greater than 0, we need to find delta greater than 0, so that if we are, where to go? This close to A, our outputs will be arbitrarily close as somebody wants it to be to C. So in general, that's what you're always doing for every one of these. If you write this down for yourself, you will know what you're looking for when you do the side work. Some people skip this step and they get all wobbly. They're like, what the hell does this mean what I just wrote down? You didn't give yourself a way to figure that out. So this is our target. How do I prove this? I find a delta, and then I show that if this, then this. That's why the side work is not proof, because the side work does not do that. Okay, maybe. And again, this is a weird one to kind of review this because it's a weird one. So let's try this out. So how do I do this side work? I start here. What is the function? What is the function? C. And this is that 0 I said, right? So you get this. Is that ever not true? Is that ever, I love you guys, look at me. What is epsilon? What's the only thing we know about epsilon? It's greater than 0. Is that ever not true then? That is always true. What does that mean then? What do we have to pick for delta? I said that the wrong way on purpose. What do we have to pick for delta to make epsilon, to make this work? Whatever the shit we want to. I don't know if you guys, there's no restrictions. Delta doesn't have to come in and save my ass, because no matter what I pick, it's always on top. It's always close. How close do you want it to be? Because it's always 0 away. I don't have to have any restrictions to make it close, because it's always on top of its limit. This is a beautiful example of a problem that is so easy that it's hard, right? And again, do not take that to mean that you feel bad because you don't get it. It is so easy that it is hard because it doesn't fall into the normal flow, because this is weird. We're not used to having a function that's always equal to its limit. We don't work with horizontal functions all the time. So then how do you finish it up? You say, well, any delta would work. Let's see. All right. So what do you want to let delta be? It doesn't matter. Give me something. 2. All right. So let delta. All right. So now proof. Let delta equal 2. If x minus a is less than 2, all right, then what is f, let me see how I want to say this. What is f of a What is f of a? How do I even want to do this now? C. All right, let me see. Let me think. This is so weird because I didn't think about. I'm done when I do that. I just say any delta will work. So let me think about this for a second. How will this look technically? Okay. Oh, okay. Okay, this is why it's so weird. Then f of x minus c equals c minus c is less than epsilon. That is true. That is why that is weird. That is why it doesn't matter what I pick for delta, because of this. What is always true about this? What is always true about this in this problem? It's equal to 0. So it's less than any epsilon they give me. That's the point I was trying to make earlier. That's why it took me a second, because I'm like, what the hell would this look like? Exactly, that's what it would look like. That's a weird one. If that's the only one you had trouble with, except for maybe one later, you're doing pretty good. Yes?
How's that number 36?
Yeah, this one.
Is that the one later?
That's the one later, exactly. Has anyone tried this one out? All right, that one is one similar to the problem we did where we had that c, do you remember? We broke it up into x plus 3, x minus 3. Okay. You have to do something similar here. So this is kind of like a bonus question. Does everybody understand what I'm saying? Yes? That one was weird. The other one we just did was weird because it was too easy. It was so easy it didn't flow the way we thought it should. We were basically done the minute they put the problem on the page. This one is hard because it's hard. Just straight up. All right, so on this problem, at least set the problem up. We need to find blah, 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 blah. Do that all. If you can't get past a certain point, that's okay. All right, I just wanted to give you a problem that was not linear. And that was not like x squared, because we already did one like that. Maybe. I don't know if you guys are understanding. There will be some homework problems that are sort of extra credit kind of problems, that if you don't get them, it's not the end of the world, and when enough people do them, I will go over it. Like on the review day, I can go over this problem. I'll assume most people have had a chance to try it out. All right. So let's do this. Well, yeah, let's do this. What would the first steps of this look like? Let's write this down. All right. At least this isn't weird in the sense that it's too easy. It's definitely not that. So given epsilon greater than 0, what do we need to do? We need to find a delta greater than 0. And again, what do these represent? What do epsilon and delta represent? What do they represent? Distance. Epsilon is a distance on the which axis? The y. It's okay. Distance is important. They normally represent very tiny distances. In theory, they could represent any distance you want to, but we consider them to mean very tiny because that's the whole point of a limit. Epsilon is how far away they want me to be from the limit. Delta is what I can control to make that happen. So that's on the x-axis. Okay, I like it. So given epsilon greater than 0, we need to find delta greater than 0 so that if we are Jeff, not if we are Jeff, if we are this close to the input, okay. So part of this is just, you all know what absolute value means. You're just not used to reading it as an English sentence. So that if the distance between any input and 2 is less than this, right? Absolute value means distance. Subtraction means distance. The distance between an input and 2 is less than delta. So I'm close to 2. for my inputs, that would force my outputs to be close to 1/2, right? Then the outputs must be this close to 1/2. Okay, so I just want to make sure you all have the same beginning spot on this problem. I'm not really going to do much more. Some of you guys realize that you want to see the connection between those two, right? And it's not as direct a connection as you wish it was. My God, if somebody tells me that 1 over x minus 1 over 2 equals 1 over x minus 2, I think I'm going to throw up, right? So if you were about to write that, or if you did write that, erase that from existence. Is that true? Obviously it's not. Arg. Okay. So it's not quite that simple. Give you a little hint. What do you do when you have two fractions subtracting? You get a common denominator. Okay. Yes, is that right? You need me to enunciate that. Get a common denominator, put them together, see where that goes. It's going to be very much like the x squared problem we did, where we had to say if x is 1, and that kind of told me what that was. There's a problem just like that in the examples. It would help you with this problem. Remember, this is sort of a bonus question, right? So if you don't get it, don't beat yourself up. Okay. Anything else from homework or yes?
2.333.
Oh yeah, okay. What happened? Where'd you have trouble with this one? Which part? Was it part A?
I think so.
Is everybody okay with doing part A of this problem?
No.
Okay. Get this going. Show off my TI emulator. Let's see. If it'll work. No, I don't want to help you improve it. Ha ha ha, I'm evil. Okay. Ooh, it's all fresh. What happened to you? There you go. Thank you. All right, so real quick, if you have your TIs, let's put this function in here. Let me show you what to be careful about. If you want to play along. If you don't, just sit there. So it's number 33. So if I do this, and please, I helped somebody out earlier. I'm not picking on you at all. Many people do this. What have I done wrong if I do this? Have I done anything wrong? Isn't that the function they gave me?
No.
Okay, what did I do wrong?
Is it -1 supposed to be in the box?
Supposed to be in the where?
And where do you make it?
In the square root?
Yes.
No, right? Do you have your book? Do you see the problem? The -1 is not under the square root, but it is supposed to be in the denominator. What have I not done? Poor TI, thank God, the TI does not have eyeballs. That would be so freaky. So we got to help it. It can't see the big ass division bar. All I can see is the divided by symbol. It's not a big ass division bar. So what do I have to do, of course, to parentheses around it, to tell it, oh yeah, calculator, you're blind. Sorry, calculator. The bottom is all this shit, right? So let me go back. No, Jeff, you can do it, buddy. Can you do it, Jeff? No. Go home, Jeff, you're drunk. All right, I have no idea. So insert, I can do a little insert, square root. Jeff, good morning, Jeff. Insert parentheses. All right, so now let's see if we do zoom 6. It's always a good idea to do zoom 6. You can kind of see where the trouble spot is. It kind of matches up with what the questions asked me for, right? Once the limit as x goes to 0, Can you kind of see a trouble spot there? I don't know. Can you guys see right there where it kind of gives up a little bit? I don't know what it looks like on your calculators. Does it look like that? Yours might have better resolution than mine. I don't know. Does it look like it goes straight through? Okay, it's all right. My poor little one, for some reason, has bad resolution. So let me do one thing. Let me zoom in on that. I'm going to do a zoom box. Have we done that before? Good old zoom box. Go up, hit a corner, and then open my box up. There we go. Whoa, Jeff. Damn. Calm it down, boy. All right, here we go. That's a little better. Why am I doing this? Just because. Why not get closer to where I want to investigate, right? So now that kind of enhances. I don't have that same thing, but watch this. Watch this. So that looks like it's continuous, doesn't it? Because there's like less than a pixel's worth of problem. You guys understand? Let me stop for a minute. You got to let me know if you're not with me. Is everybody with me? The zoom box thing, have you kind of gone in closer? Okay. So watch, a couple things. If I try to calculate, see above trace, second trace. If I try to calculate the value at 0, calculator, look at this. I love this. Calculator's like, I wish they had that symbol on there, little emoji. So how do I investigate this then? Let me just use trace. So if I get closer and closer, what's it look like the outputs are doing? In fact, that's pretty damn close right there. Look at that. I don't know if you guys, depending on how you zoomed and what your resolution is, you might not be able to get that close. Can anyone see why that's really close to 0? How do I know that's really close to 0? Not just from up here, but what is this? It's like 0.00019. I'm really close, but you can. So what's it look like the outputs are approaching then? 0.666. Yeah. Okay. And of course, part B I think is make a table, so you can look at that more specifically. Yes.
I can't find trace on my calculator.
Oh, right up here. See there? Let me try to make this bigger. You could do it, Jeff.
Okay.
You got it? Okay. Why can't I make you bigger? Oh yeah, that's right. I forgot. Just do this. Look at that. Oh, sweet. So it's right there, yeah. Okay. Yes.
So are we allowed to graph stuff on this board?
Why was this one where you could graph it to get the answer?
Did it say it in the problem?
It's said to, yeah. It's got the little graphical symbol. If you are not certain, especially on a test, if you are not certain, do not use the calculator to answer the question. If I were you, first thing I would do on many problems is graph it. I mean, I'm just going to be honest, right? I'm always surprised that some people don't do that. You didn't say I could. Who gives a shit? You graph it just to get a feel, so then when you start to do the algebra, you're like, that's not going in the right direction. Oh, shit, what have I done? Does that make sense? Okay. But I love it when I'm like, show your work, and somebody's like, well, I hit this button, and then I hit this button, and then hit. No, that's not work. Okay. Is that? Yes.
Why did we do this?
Because it told me to. So, I love that question, because it's an easy answer. What does the problem part A say?
Yeah.
Holy shit, Jeff. Yeah, graphing the function.
Oh.
I love it. So that's beautiful. That's why somebody was like, why can't we do it here, Jeff? Because they said to. No. Make a table. I'm cool with you using the table in your calculator to get the values, then you just copy them down. I love that shit. Why is that good? Because I already put the function in my calculator. Might as well make a table in the calculator and copy it down for part B. So A and B are sort of the same, right? When I trace, I am indeed putting values closer and closer. I'm just doing it visually. And that's the point they're trying to make. And then part C is what can somebody tell me one word to help others to do part C? Anybody? What do I do to do it algebraically?
Rationalize.
Rationalize, sorry. I like it.
Radicalize the numerator.
Yeah, I like it. Yeah, that's another way to look at it. To rationalize one part, you got to radicalize another part. Yes?
But it doesn't say graph it, it says estimate the value by graphing.
Yeah. Yeah. So by graphing, estimate the value. Estimate the value of this by graphing, estimate the value of this by making a table.
What does that mean?
So you graph it, and then you estimate, just like we did. We got really close to it, and we could see what it looked like it was going to. Part B is do part A, but do it in a table. Do it more explicitly. Show me the numbers and show me they're going to 0.666. So part A is just graph it and look at what it looks like it's going to. I tried to plug 0 in, and it didn't give me an output, of course, because it's not defined at 0.
You mean crossing the y-axis?
Say again?
You mean crossing the y-axis?
Okay, yes. So essentially we're trying to find what this guy's y-intercept should be.
Okay.
I see what you mean. Does that make sense
Yes.
to anybody else? Yeah, because x equals 0 means the y-intercept. There is no y-intercept, but what would it be if this thing didn't have the problem it did? Yeah. You like it? I love you guys. Okay. Who knew calculus would be weird? Anything else? Okay, we got a lot to do. First thing I want to do is ask again if anyone is missing this worksheet here. Okay, let's see. You might get some of my notes, which is, I think you'll appreciate. Oh, those notes I don't want to give you. Actually, those notes I don't want to give you. Well, shit. Here, I'll give you this one. Has everybody else got that sheet? Think on. This one's got a little bit of squiggliness on it. Oh my goodness. We need some help. There we go. Okay. So in the interest of time, we're going to do this one together. A problem like number 1, I would think that we all should kind of eat it up. It's very concrete compared to some of the other stuff we do. It's pretty obvious where there are discontinuities. So just where are there discontinuities? For what x values? Yeah, there's a x equals -3. X equals 3. X equals 6. And that's it, right? Yes?
Why would you write it like that and not the 2 points for the...
Oh, I see what you mean. Because at those points, I don't want to put -3 this, because, how do I say this? That isn't saying there's a problem there. If I just say that, it makes it seem like everything's great. So this is all about where are there problems. Let me say this. A where question is an X answer. X tells me where things happen. What happens there is the Y answer. So if I said, where is the output 7, you would tell me an X. If I said, what is the output at 3, you would tell me the Y, right? Okay. Maybe. Yes?
Wasn't there like a thing with absolute value functions where it's not zero?
Oh, no. You're getting a little ahead. It's not differentiable at 0, but we're going to get there.
Yeah, okay.
That's a plane you would not want to be on.
Yeah.
Thank you for flying American Airlines, and now we're all dead. Way too hard of a turn. Right? That's coming up later. All right. That is completely continuous through 0. Do you guys agree? It doesn't matter. There's a hard turn. I can draw that without picking my pencil up if you want to use the kind of hand-wavy way to define continuity. I can do it without picking my pencil up. Okay. Now, anybody see any other spots besides these 3 that we have to worry about? No. What's happening at -3? Who could be more specific? Jump. Jump. What about at 3? Infinite. I like it. And what about at 6? Removable. And do you see how the city tried to remove that pothole? They tried, but again, they put the filling in the grass beside the street. I don't know if you guys like that analogy. That's what I like about removable. Couldn't they have removed it if they would have just put that there? wouldn't there have been no discontinuity then? So that's why we call it removable, because it could be removed if you just fill that circle in. Ah, shit, they were off by a little bit. So now we got a pothole and a bump. Yay. Thanks, street. Thanks, city. You guys cool with that? I mean, that should be pretty good. That's nice and concrete definitions. That should be no problem. This one, we started on a little bit. So I try to show you the first few things to try to do, but you do have to keep an eye on kind of everything a little bit. But what is the definite first thing you should do on this problem? Yeah, plot the points that we know. Those are the things we know without any question. So -3 goes to 2, 0 goes to 0, 2, -1, and that's it. That's all we know. I don't know any other function values. Now, there's a few different ways to approach this. Let's do this. What's happening below -3? Is there anything interesting happening below -3? The only thing is this, right? Everything else is happening above -3. Does that make sense? Yes.
Why did you plot those exact points?
Because I know this for sure. I can plot that point, right? That's a point, that's a point. They're not limits, they are function values. Thank God, they're just points then. That's why I start there, because those I know for sure what the hell's going on. Now I'm going to kind of attack it as we read. This is one way to do this. The only thing I have to be careful about on this side is what? What's the only thing that the function needs to do over here? It's got to approach 2. Right? Are you guys okay? You guys with me? Because there's no other specification for any numbers down there. That's an awesome little place. You could do whatever the hell you want to. I do normally end up making a little squiggly, but you could do this. Yeah! Or you can come from up here. Woohoo! Does everybody understand why you have flexibility there? That's all it tells me about the freaking function is it has to go to 2 as my inputs approach -3. And that, of course, means what happens on the other side of x equal -3. Right? What does this mean? Is this specifically from one side or the other? Yes?
Why did you come from the left side?
Because I'm going in this direction first.
Why?
Because I wanted to. So there's many different ways you could do this. It's a little bit easier if you just sort of like go across as you read.
So could you draw the line going that way?
I have to. So because this says it's approaching 2 from both sides.
Okay.
But it is kind of nice. That means from this side, I could just, it doesn't matter. I can do all kinds of shit. As long as it goes to 2, it has no idea what's going on back here. So there will be how many answers? As many answers as takes the quiz, right? And the test. Each of you are going to have a little bit different answer to this problem. Okay. And like you said, on this side, I have to go to 2 also, right? But now I got to be careful. What's the next thing that I have something that I need to do? 0. So which one is talking about what I'm doing now? Which one? 1, 2, 3. 3. So from below, from the left, as I come to 0, I've got to approach, my outputs have to approach 1. What does that mean is going to be right here? Open circle, because it's already defined to be there. I like it. One mistake I see is people put a closed circle, that's not a function. And this whole thing is predicated on this being a function. So it's got to pass vertical line test. I really want this. So as my inputs approach 0 from the left, my outputs have to approach 1. Now it's got to happen as I leave that. What up here tells me what to do as I leave this. Yeah, what's happening on the other side of 0, I've actually got to approach -1. Let me stop for a minute. Are you guys, this is not the only way to do this, but you need to come up with a way that kind of systematically does this so you don't miss anything as you're going. That's why that big old first side was fantastic. I could just do whatever the hell I want to, as long as I connect it to 2. Now I've got to be really careful. So now we got to start from -1 and go this way. So now what's happening, my function, as I approach 0 from the right, I am approaching -1 like this wants me to. But I just put a little tiny stem because now I got to be careful about the next point, which is 2. What's going to happen at 2?
Y0 Y0.
Is y 0 at 2? Be careful.
Oh no.
What kind of thing will be at 0? Open circle, kick ass. Right? So now we're looking at this guy. So from below it's got to go here, and from above it's got to go there. And what's the next place? Yeah, the next thing I got to be careful about is 5. And that one we got last time. What's going to be at 5 graphically? True. So what's going to be there?
Infinite.
Asymptote. I love it. Asymptote. And then it's going to be an infinite well, because as I approach 5 from either side, I've got to go down forever. Holy shit. And then is that anything else past 5? The only thing is I got to come from there, right? And then I can do whatever the hell I want. All right. As long as it's still a function, don't come back on itself.
Could you come from above?
How do you mean? Sorry.
After,
from up here?
Yeah, after that.
Why not? Because then if I came from up here, what's happening as my inputs approach 5 from this side, the outputs are going to positive infinity. They're supposed to go to negative infinity on both sides. I like it. Okay, maybe. Is that all right? It's always easier to just watch me doing this, but hopefully you guys came with me on that. Okay. All right, number 3. So on number 3, there's obviously inputs where we have to be careful. How do I know the parts are continuous? So people focus way too much on the individual x values. I'm asking you to show me that g is continuous, which means for everything below -1, it's got to be continuous. Is that true? What kind of function is this? Linear, more generally, polynomial. And what do we know about polynomials? They are continuous everywhere. Right? So you would say, yes?
I look at this and I have no clue what to do.
What does the function look like for inputs -1 and below? What does the function look like? Looks like a straight line. Is that cool? What does the function look like for inputs between -1 and 1? Looks like freaky ass 1 over x. Can you guys do 1 over x in the air for me? Anybody? You have to use both hands to make it easier. Yes, like that. Right? It's the most basic hyperbola. Yes, it's like this. It's a hyperbola because they're like 2 parabolic looking dudes across from each other. It's the most basic hyperbola. Okay. Are we going to have to sketch this? Does it say to sketch it? It wouldn't even be helpful, to be honest. No, we don't have to sketch it. Isn't that great? Yeah, thanks, Jeff. Okay. What kind of function is this? Don't tell me the shape. What kind of function is it? Rational. And what do we know about rational functions? Continuous everywhere on their. So does that have an issue? Where would that have an issue? What's not in its domain? Infinity is not really in anybody's domain. I love you guys. 0. Yes? And is that where we have defined it to be? Shit! So we've identified, what have we just identified? A location where the function is discontinuous. Because again, rational functions are continuous everywhere on their domain. Damn it, one of the inputs we're allowed to use is not in its domain. Yes?
Wouldn't there be another one at 0? Another, there would be like a jump discontinuity after it. I mean, I'm not 0, it's equal 1.
Let me catch up to you. Hold on. Say again?
There would be a jump discontinuity of 1.
Oh, we're getting up to 1. Hold on. At 0, it would be like an infinite, but the infinities don't even agree, right? So that's bad. This is limit is infinity. This is limit is negative infinity. This is limit does not exist, and I can't be more specific. It just doesn't even agree on how it freaks out. Maybe? Maybe? No? Is everybody with me? So this guy didn't have any problems on this. This guy had a problem at 0. Does this guy have any problems on this domain? No, that in fact is its domain. You guys agree with me? X has to be at least 1 for that to exist, so it's like, yay, I'm happy. Now, what's the other? So, do you guys understand what just happened? What I said earlier was people focus so much on the connector points. What do I mean? The -1 and the 1, right? Those are connector points. If they don't connect, it's a discontinuity, yes? And then they forget each function itself could have a problem. So do that first. Look at each function themselves. So we've only identified one place. Now look at the -1 and the 1. So is there, what do I have to check out at -1? What do I have to make sure happens for it to be continuous? What needs to happen? You guys know this. What needs to happen at -1?
The 2 functions need to be.
Yes, the function on the one side has to meet the function on the other side, or else the open circle doesn't get filled in. Is that cool?
No.
So, if I had a function that did this, is that continuous at 1? No. So I've got to look at the function that's defined in this direction and the function that's defined in this direction. Do they agree at that point? So when does the function stop being x? When does it start being something else, defined by something else? At -1, yes? Okay. At -1, what does this want to be? -1. At -1, what does this want to be? -1. So this guy would be the open circle, yes? This guy would be the open circle. Why? Because it's not allowed to use -1, but then this guy would come and fill it in. I love it.
Is that because it doesn't have the line under the...
Yes, all right, so the reason this would have an open circle is because it's not allowed to use -1, but I would put an open circle where it wants to be. Yes, and then the other dude comes in and fills that in. Actually, it would do like this, of course, right? X, bam. It would fill that in, and then this guy takes over. So they agreed, so is that a problem spot? No. What about at x equal to 1? What is 1 over x? 1, that's right, kids. And what is the square root of x minus 1 at x equal 1? 0. So do they agree? This guy puts an open circle at 1. Then this guy picks up at 0. Shit. They didn't fill the pothole in. So that is another discontinuity. So where is this continuous? What's the answer to the question? Negative infinity up to 0. I love it. And then from 0 up to 1. And then from 1 up to infinity. So I think you all know, on a piecewise function, you definitely want to check out the connector points. Where does one function stop and the other one pick up? That's a pretty obvious one. The one that people forget is, do the function pieces themselves have issues, right? So do that first, so you don't forget. Okay. And then number 4, this is the one that I definitely don't want to use tables on these. You've got to consider what's happening. So let me show you a little trick. What is x squared minus 4 itself going to? What is the limit as x goes to 2 from above of x squared minus 4? 0. And it's going to 0. Think about this. I really want you guys, this is kind of a cool thing we're going to use in a minute with infinities. Every value as I approach 2 from above, are they negative or positive? Every value that I get out of x squared minus 4, if I put values, what does this mean? All the inputs I'm putting in are above 2. They're all bigger than 2. So what's true about these outputs? Are they positive or negative? Positive. Which means all the outputs are approaching 0 from the right. They're all positive, correct? They're always positive, but they are definitely going to 0. Are you guys? I love that. Some of you guys are okay, and the rest of you are like, I remain neutral. I am Switzerland. Guess how I feel, Jeff. I'm like, I don't. Okay, I really want this to make a lot of sense. It's obviously the limit is 0. That kicks ass. If only the question was this problem would have been freaking easy as shit. Why am I being a little more careful? Because the problem isn't this. Thankfully, this is going to 0 from above, because could I go from 0 to 0 from below for natural log? What happens below 0 for natural log? It is undefined. I could never do that problem. So watch how I can rewrite this. Let me see if anybody likes this. I can rewrite this as, let me replace x squared minus 4 with t. And what did we just say that those t's are doing? What is happening to this as I approach 2 from above? They're going to 0 from above, from the right, sorry. Thank you. So this is t goes to 0 from above, from the right. Do you see how I rewrote the problem so I can look at it more directly? Now, this is a problem I think from the homework, I can't remember. What's happened in the natural log, of course, as I approach 0? Negative infinity, yes? And this is where, if you know the basic look of graphs, you will remember their domains much easier. When I think natural log domain, I think of its picture, and then I remember, oh yeah, it's from 0 to infinity, not including 0. No? Maybe? Yes? Maybe? So this is going to be negative infinity. Did I have to do the t thing? Not really, no. If I could just keep track of what the parts were doing. What do you do in part B? Sure. Yes. All right. So if I plug in 3, I get 9 minus 9 over 9 minus 18 plus 9. That's 0 over 0. You guys with me? Why do I do that first?
Make sure there's natural limit.
Yeah, if I do that and I get a number, or if I get 1 over 0 or 0, I'm done. I don't have to factor. Do you guys understand that? Do you think I'm going to give you a problem like that? Yes. So there's going to be people like, oh, I factor this. And I'm like, no, you just have to plug the damn thing in. So the first thing you do is there a problem I have to take care of? Can I not just determine what the answer is? In this problem, it's indeterminate, meaning I have to do something. So, go ahead and do what you said, because now we see there's a problem. The top I can factor real easy, of course. And what's the bottom factor to be? I like it. So what happens there? You guys with me? 1x minus 3 cancels. Now what's neat is, did I take care of the problem? Not entirely, but is this still indeterminate? Do you guys see what I mean? Isn't there still a problem? Does this function like 3? It still doesn't. So why is this not indeterminate? Because now it's in what form? 3 over 0. I like it. So anytime, so watch what I'm going to do. In parentheses, I'm going to put that. Because if you just write that, that is undefined. You've just written an impossible thing. You gave me a sphere with corners. And my brain might explode if you do that. So put in parentheses, tell me, oh, that's the form it's in. So what does that mean the answer is? Now, how do you know it's positive infinity? What are the bottom values as you approach 3 from above? Are they negative or positive? So you're always plugging stuff in that are bigger than 3. Subtracting 3, it's positive. So if that would have been a little negative sign, the answer would have been negative infinity. Can you guys see that? That's why this happens. Okay, maybe. Because, again, when I put values in that are bigger than 3, the top is obviously positive, and the bottom is positive. So this will be positive infinity. In fact, to be really, really careful, I would put that plus symbol in case there's a stray mark that looks like a negative, right? Really make sure, Jeff, it's positive infinity, dude. Okay. I'm sorry, yes?
I'm a little confused. I get how you got the positive infinity, but you just said put 3 in and then you calculated that.
Sorry?
So like, for the first step, you took out an x, and x minus 3 on top.
Yes.
But before that, we were talking about plugging in the 3s, so okay, we plug in the 3.
Oh, we put in the 3 just to make sure that this wasn't something I could answer immediately. If I would have put a plus 6x there, you plug a 3 in, you get a number, you're done. Why did I have to do more work? Because we got an indeterminate form. 0 over 0 is our first indeterminate form that we know. Okay. I locked it. Yes?
So, how do you know if it's positive infinity or negative infinity? Like, how do you know if the reciprocal function is tanking or here?
So look at this. All right. 1 over x. Right? Why is the limit as x goes to 0 from below negative infinity? Because when I plug numbers in, what kind of numbers am I plugging in?
Negative.
Negative. And these outputs are always negative. They're getting bigger negative. So look back at the problem we just did. Same idea, exactly the same idea, but now it's all about 3. But if I'm plugging numbers in that are bigger than 3 always, then the bottom is positive. So that's going to positive. What would happen below it? Like that. That's why that happens. Okay, maybe. It's a little warm in here. Or is it just me? It's probably just me. Okay. Oh, let's look at this last bad boy here. Let's see. How can I rewrite this? So it'd be x over sine x. Right?
Oh, the times the, oh wait, no.
Is that right? Okay. Is this indeterminate? No. This will be pi over, what happens? 0. That wants to be some kind of infinity. Don't just write infinity down. What did we just figure out that we got to make sure about? What are the bottom values? The top is positive, right? Top's like, I'm all good. What are you doing, bottom? The bottom's like, what the hell am I? So what is happening to sine if I am putting values bigger than pi? If I'm putting values bigger than pi, what quadrant am I in when I get close to pi? Third quadrant.
Yeah.
What's true about sine?
It's negative.
It's negative. So what kind of infinity will this be? Negative. Holy shit. Okay. You guys understand? It's exactly the same consideration we took on the very previous problem. Top, all good. Bottom 0, but how is it going to 0? From below or from above? Yes? This one, same idea. So bigger than pi, sign's negative, the whole thing's going to negative infinity. Okay, whew. Yes?
And then if it didn't have a plus or minus sign on the number as like the limit is
Oh, you mean like this guy?
yeah, so this
Ah.
does not exist.
Yes.
Okay.
Because the infinities wouldn't even agree. So I
Yeah.
really want to make sure you guys understand. This limit does not exist. It does not exist, but we can be more specific about how it doesn't exist. It doesn't exist because it goes to negative infinity. So if I have like this, what would that limit be? Infinity, positive. If I have this, what's that limit, period, does not exist. It doesn't even agree on how it's freaking out. Does that? I know my language is very technical. No, not really. I try to talk about it just in everyday language. Do they agree with how they're freaking out? No. This one, they're like, we're freaking out. How? Up, holy. Okay, so that's infinity. They agree on how they're freaking out. These don't even agree. So that's just flat out does not exist. You can't put any kind of infinity because they don't agree. Maybe. Okay. All right. So you would be wrong in this problem if you just put DNE, because you could be more specific about how it DNEs. Okay. Any questions from that entire thing? These are the kind of problems I enjoy giving you on quizzes and tests. Yes?
I'm sorry, I know you just said it, but like sorry, it's negative constant.
Sorry, say again? Why is this negative infinity?
Yeah.
Because, what does this mean? My inputs, how are they related to pi, all my inputs? What does that plus sign mean? Greater than pi. So all my inputs are bigger than pi. What quadrant am I in if I have angles greater than pi?
Oh.
I'm in the third quadrant, correct? So I'm going like this. And what's true about sine in the third quadrant? It's always, you can do it. Sine, sorry, did you say it? What's true about sine in the third quadrant? It's always what kind of number? Negative. That's why it's negative infinity. Because those are getting really, really tiny negative. So the whole thing's getting really, really big negative. Love you guys. What would you do in your calculator to kind of double check this? What do you think you'd do? I would put 3.2 in. Why would I do that? Because it's close to pi and it's above pi. And then I would put 3.15 in. Do you guys understand? Because that's following what the, so I'd make like a little table. I could just put a couple values in and make sure they're getting really big negative. If you want to try that out right now, you can. Or if you don't want to, it's fine with me, right? But that's how you can kind of double check a problem where I don't say you can use a graphing calculator. You still freaking should. Because it's just, you got it. Why not? Why not kind of check to make sure it's making sense?
So you know how you just said negative infinity is being more specific than does not exist?
Yes.
So then when, like in your case, when you put the...
Oh, like I said, if I would have not had the plus sign, right? Because then, as it goes from the right, it would be negative infinity, because that would, sign would be negative. And if it goes from the left below pi, now it's up here, right? Those signs would be positive. That would be positive infinity. So do they agree? No. That would be where you just put a flat, does not exist. Yeah. Yes.
You were talking to him, if you put a plus 6 right here, it would be 0 over like 36. So
Then the answer would be 0.
still be, okay.
I really want that. So watch. Okay. So what if this problem was this? Right? People are going to factor. Sometimes people will factor and they'll force it to be the wrong thing so that something happens. But what do I get when I plug a 3 in? I get 9 minus 9 is 0 over 9 plus 18 plus 9. 0 over not 0. You guys with me? No? If I put a 3 in, Don't I get 0 over 36? Yes? And is that indeterminate? Can you not determine what 0 divided by 36 is? What's 0 divided by 36? I'm done. I'm not going to waste any time factoring or conjugate stuff or any bullshit. So please understand, I'm not going to do that. I'm going to have like one problem like that, because if I put a lot of problems like that, you could double the time that you should be taking to do it. You guys with me? But just check it every time. Check. Is it indeterminate? I really want this to make all this. If it's determinate, that means I can determine the answer. Why would I do anything else? If I could determine the answer, why would I just determine the damn answer? Just like this. That is determinate. But 0 divided by 0, that is 0 and infinity at the same. Oh, what the shit? That's indeterminate. I got to do some more shit to it. I got to factor. I got to conjugate. I got to combine fractions. Whatever the shit. Maybe. That name is so beautiful. Determinate versus indeterminate. Okay. Anything else from that sheet? Holy sheet. Okay. All right. So. Oh, that's right. Okay. We got a little bit of time. I'm going to do a little bit of work. See if I got some paper. I don't know if you guys have picked up on this, but I am not used to using the overhead. But using the board in this room doesn't really make a lot of sense. So I really suck at the overhead thing. But let me know if I think you guys have done a good job of telling me if I'm off the screen. Okay.
Wait, so did you teach an election law before this?
Say again?
Did you teach an election law?
Every semester is different. So, and it's been a while. It's the first time I've been in a room, in a while.
Yeah.
I can't remember where I was teaching before the pandemic. Those are the olden times. All right. Back in the before days.
Is this 2.6?
2.6. 2.6. Okay. Can somebody attempt to tell me? I think you guys can see what I'm trying to make there. Can somebody attempt to tell me what that means? Think about it for a minute. Yeah, okay, good. All right, so one answer would be horizontal asymptote, kick ass. And I loved your pre-calc teachers if they actually used the limit symbol to get you ready. And as I say that, I'm like, did I do that last? I can't remember. Yes.
The y-intercept is L?
All right. So y-intercept is when x is 0. Yes? And I'm letting x go to, I'm trying to let x go to infinity. That might be, let me write this again. My little infinity became a weird, yeah. Okay, right? So this is way far away from the y-axis. What else does it mean? As I let my inputs, yes?
As x gets larger, what value is the output?
Okay, good. So as my inputs get larger, my outputs have to, starts with the letter A, approach a certain value, right? So let me make it really, really, really technical, right? What I just said is sort of like the everyday way to say it. As my inputs get arbitrarily large, my outputs approach L. All right, so what is this technical? Let me write the technical definition. No, I'm gonna, before I write this, in this section, you're not gonna have to do proofs. But I just want to write this language for us, okay? So let me say that before I start writing this, because somebody out there is gonna have a little mini stroke if I don't do that. So you are not gonna have to do proofs in this section. Given epsilon greater than 0, we can find m greater than 0 so that if x is greater than m, the distance between the function and L is less than epsilon. So think about this. If I'm supposed to be approaching something when I let x get really big, and somebody says, okay, I want you to be this close to the supposed limit, I have to be able to find an m so that all inputs after that stay that close, no matter what. If I can never ever find anywhere where they stay that close, that can't be the limit, because what's the whole idea? Eventually it has to get close. Yes? So this captures that very simple statement, eventually it's got to get close, in terms that hopefully we're more familiar with. So somebody says, I want you to be this close to the limit, I want the outputs to be this close, and I have to find a place m where for every input after that, it's that close. And then they go, well, I want it to be that close, so I'm going to have to go a little further out, maybe. I want to be that close. Yes, maybe. Maybe some of you guys are like, sure, I'm just happy I don't have to do it. Yes?
Wondering why we use n instead of delta.
Because delta inherently means small, even though technically you could be anything.
Is n specific as a point, or
M is another number, but it kind of means big in this case, right? Because I'm letting it go into infinity. So epsilon and delta are inherently understood to normally be able to capture small distances. So here I didn't want to use delta because I want to capture large. Yeah. Okay. Like it, baby. So it is the location of horizontal asymptotes, as somebody pointed out. So look at this. What about this function? Who knows anything about this function here? Anything? Tell me anything, even just how to read it. Yes?
There's asymptotes that pile to the negative part.
What kind of asymptotes?
Vertical asymptotes.
No. I really want this to make all the sense. So tangent has asymptotes at, vertical asymptotes at negative pi over 2, pi over 2. So inverse tangent has what kind of asymptotes? Horizontal, negative pi over 2, pi over 2. Because again, this is so beautiful. Inverses switch everything to do with domain. They switch it with everything to do with range. So if the inputs had to be between negative pi over 2 and pi over 2 for tangent, the outputs have to be between negative pi over 2 pi over 2 for inverse tangent. It kicks so much ass. You have to let it. Okay, maybe. So what kind of asymptotes does it have? Does it have the kind that we discussed right up there? Yes. Because as I let x's get really, really big, what must my outputs do? Jeff, you could do it. There you go. If I let x get really big towards positive infinity, my outputs have to approach pi over 2. But then we see this side. What's going on this side? You can do it, Jeff. Why am I having so much trouble? I can't make infinity symbol. Is that going to be a problem? How much paper do I have? Not much. Okay. Okay, the limit as x goes to positive infinity is pi over 2 because there's a ceiling there. And of course, what's this side mean? Negative infinity, right? Negative pi over 2. So there's an example of a function who's got two different horizontal asymptotes. In pre-calculus, you're really used to looking at rational functions where they normally have one horizontal asymptote that goes in both directions. Yes? Remember that stuff? Okay. This is a very nice example of one that's got a different ceiling and a different floor. Yes?
Can you explain how you get the pi over 2?
What's tangent of pi over 2? Think about it. So I mean, here's the thing. Tangent, let's see, I don't want to give a lot of space for this. Tangent is, of course, between negative pi over 2, pi over 2. You gotta remember this, yes? That is a really, really rough sketch of tangent. So if I invert it, it's going to look just like that. And of course, remember, real quick, tangent, does it just live between negative pi over 2 and pi over 2? Tangent? Of course not. It repeats forever. So we restrict the domain, of course, so that we can create an inverse function, because otherwise it's not even passed into horizontal line test if I let this go forever in both directions. Does that sound familiar? We had to restrict the domain of sine to find an inverse, restrict the domain of cosine, same thing with tangent. Okay. I love you guys. Okay. All right, I think the last thing I'm going to be able to sneak in today, all right, let's talk about this. Last thing. Let's look at this function here. I will. Thank you, though. Put your pre-calc hat on. And some of you guys are like, damn, dude, that's dusty. It's in my closet, in the back of my closet. If I wanted you to graph this, what's one of the first things you should find besides intercepts and vertical asymptotes? You also want to find horizontal asymptote, yes? So how does anyone remember? There's a shortcut that I don't want us to use quite yet. Does anyone remember the shortcut for this specific kind of rational function? Powers, sure. Something about the powers. Anybody remember?
Oh, if the powers equal each other, it has like divide.
Yes. And please let this make sense. If the powers are equal, that means the top and the bottom are growing at about the same kind of rate. So they constantly kind of kill each other at the same rate. So that means that in the limit that x goes to infinity, there must be a number they sort of approach in ratio. If the bottom power is bigger, the whole thing dies, goes to 0. The bottom power is bigger, bottom's growing much faster, so the whole thing is going to 0. If the top power is bigger, what kind of asymptote do you get? Slant or oblique. Remember you had to do long division? Does this sound familiar? Not at all. Some of you guys are like, if I say it doesn't sound familiar, will he not make us do it? So if I wanted to know the limit as x goes to infinity of this, does anyone remember the longer way we do this? What was the very first way before you learned the shortcut to do this?
Was it multiplying everything by we're making x like 1,000,000 or something?
No. That would sort of be a table approach, right? So I don't want to do a table. Yes? No? All right, here's the thing. Real quick. Is x possibly 0?
Yes.
Think about it. Is x possibly 0?
Yes.
No.
Wait. Oh. No.
Is x possibly 0? No. Or could x be 0? Sure. Do I care about it? No, because I left it back. Long time ago, right? Look at where I am. I'm trying to get here. Am I anywhere near 0 to investigate this? No. So can I divide top and bottom by x, for example? Yeah. Could I? What's the only time I can't divide by x? If x is 0 and we left 0 behind, didn't we? So I can divide not just by x, I actually want to divide by the highest power. Does this sound familiar to anybody? Familiar? I just made a new word. Does it sound familiar? Herbert? No? Okay. So what do I get? I get 3 minus 2 over x plus 1 over x squared over 2 plus 1 over x minus 2 over x squared. Does anybody see that? Right, the x squares cancel, 1x cancels in the middle, and poor little 1, nothing cancels. Now, why are these easy as shit? What happens to each of these? They all go to 0, right? So then, of course, the answer is 3/2. Which I know some of you guys are like, oh, I already knew that because I did the shortcut. I'm like, I know. Before you knew the shortcut, how did you do it? That's how you did it. Okay, so let me give you guys something. is a practice test as promised. What's happening Wednesday, by the way? Yeah. You're welcome. You want more grades. Does anyone realize that yet? The worst class in the world I ever took had only an oral final exam. That was their only grade. That was just no pressure at all. Quantum mechanics. The girl in the room next to me is a good friend of mine, and she had a nervous breakdown. She just started crying. And I'm in my room like, I'll never forget that. So that's a practice test. I'll have an answer key for it Friday. Friday's review day. Wednesday, we are still on track to finish chapter 2, believe it or not. And then, of course, Monday is a holiday, so you got all kinds of time to do homework from this Friday between Friday and the next week. I think that's a pretty good place to stop. Let me know. Yes.
What's the quiz on?
Oh, yeah, what's the quiz on? Anybody remember? Yes, 2-1 to 2-5. I like it.
Let's do Friday.
The practice test, I don't want to see it. Unless you have a question, right? So you only do it if you have time. I'm going to give the answer key Friday. So it's just for you. That's only for you. All right. Let me know if you have questions. Otherwise, you're free to run away.